Hello kids, Shubhamangalam Clinical Scholar, myself Sudeep. I'll be taking up class 6 science for today. We will continue with the lesson number 2, which was playing with magnets. So we have understood what are natural magnets and what are artificial magnets. We have seen different sizes of magnets and sizes and shapes of magnets. Like we saw 4 different sizes and shapes of magnets, like bar magnet, the disc magnet, the U-shaped or the horse magnet, and the ring magnet. And then we understood what was magnet initially called as. It was called as the lodestone, which was discovered by Magnus 2500 years ago, which is really long back. And what else did we discuss, class? We discussed about the properties of magnets, so the directional property, the attraction and the repulsion property. We came across 2 very important statements that we need to remember till we study about science. It is nothing but the like poles repel and the unlike poles attract. What do you mean by like poles repelling? What do you mean by that? This means that when similar kind of poles of 2 different magnets are brought together, they are going to move apart. And when dissimilar kind or different kinds, like north pole of the first magnet is brought closer to the south pole of the second magnet, they are going to attract each other. What is this property called as? Attraction and repulsion property. Like poles repel and unlike poles attract. Now we also discuss about few examples of magnets, like we were discussing like all metals are usually magnets. But do you really think that all metals that you see around yourself will be magnets? For example, let's consider copper. In olden ages and all, people used to have copper pennies or copper coins. These days you use a alloy. But earlier in vintage times, people used to use copper alloy, copper coins. Now, pure copper is not magnetic in nature. It is not going to attract magnet. You need to mix copper with certain traces of zinc, cobalt, or nickel. Okay, when you mix copper with certain traces of zinc, cobalt, or nickel, all these 3 materials mixed up with copper, any of these, like cobalt or nickel mixed up with copper, the resultant product that you are going to get will be called as an alloy. And if that is used to make coins or any other, products, then those coins or products are going to be magnetic in nature. This is just an example, not a part of a textbook, but just for general cases, for general awareness. So pure copper or pure gold is never going to be magnetic in nature. Okay, it needs to be mixed up with certain traces of other magnetic materials like iron or cobalt or nickel, which are highly magnetic in nature. The same thing goes with aluminium also. The utensils that you see in your house, aluminium, if it is made up of pure aluminium, it is never going to attract magnet. If it is made up of a mixture, like a blend of aluminium and some other magnetic material like iron or cobalt, then that utensil is going to attract magnets. Do you understand now? Okay, this is how magnetic materials were made. Now we were discussing about the directional property. What was the directional property? If I'm going to suspend the bar magnet from a certain position, the bar magnet is going to come rest in the north-south direction. Whenever the bar magnet comes rest in north-south direction, then that property is called as the directional property of the bar magnet. For example, I have a iron block with me. I don't know the polarity of the iron block. I don't know whether it is an iron block or it is an iron bar magnet. I don't know that it is an iron block or an iron bar magnet. Okay, so what do I do now? I have another magnet with me where I know which side is the north pole and which side is the south pole. This is my magnet number 1. I have a good magnet with me where I know which end is the north pole and which end is the south pole. So I tie a thread in the middle of this particular magnet and I suspend it from a certain point. When I suspend it from a certain point, I bring it closer to this iron bar over here. Okay, now if the north pole of this end is attracting this end of this magnet number 2, Did you understand? If the north pole of my first magnet is attracting this end, the first end of my magnet number 2, and south pole of my first magnet is attracting the other end of my magnet number 2, this means this block here is also a bar magnet. Okay, because both these magnets are showing attraction properties. Now the north end is the north pole of the first magnet is attracting this end. This means this end is nothing but the south pole. Did you understand? And the south pole is attracting this end, the other end of the new magnet. Then this end is nothing but the north pole. Did you understand now? So what did we understand? If they give us a block randomly and we want to find out whether it is an iron block or an iron bar magnet, we need to bring it closer to another already known bar magnet. Okay, what did I do in this case? I was already having a good bar magnet with me where I know which one is the north pole and the south pole. I want to find the poles on this new magnet of mine. So what did I do? I brought this already existing magnet to near to this new magnet so that I can find out what are the poles of my new magnet over here. Okay, so now because the north end was attracting this particular end, I understood that this end is going to be the south pole, and the south pole of this already existing magnet was attracting the second end. Then I understood that this is going to be the north pole. Okay, so what did I discover now? I discovered that this block that was given to me was actually a bar magnet with two poles, the south pole and the north pole respectively. That is why it was attracting the already existing bar magnet over here. Okay with everyone? Now if I remove this bar magnet, okay, if I remove this bar magnet, that particular existing bar magnet which is tied to a thread and suspended from a point will still come to north-south direction. Why do you think that when I suspend a bar magnet from a certain point, even though I have no iron materials or no magnetic materials present with me right now, but still this particular bar magnet is coming rest in north-south direction? Why do you think this is happening? There must be a certain invisible force that is forcing this particular magnet which is tied to a thread and fixed from a point come to rest in a north-south direction. Why do you think this is happening? The same principle is being applicable in our magnetic compass. Okay, the magnetic compass is going to be something like this. The north, south and the west and east showing like this. Okay, now when I hold the magnetic compass, I see that the pointer is pointing to the north direction. Okay, how do you think it is pointing to the north direction? Here I understood that this particular north pole was pointing to the south bar magnet. That is why I came to in this position. Yes or no? Are you able to understand? Let's recall again. So what were we talking about? We were talking about the directional property. What does the directional property state? That whenever I am going to hold the bar magnet from a certain end, it is going to come to rest in the north-south direction. Okay, now what did we do? We did a simple activity. We took an already existing magnet, we tied a thread to it and we fixed it from a point. We brought another magnet to it to where we were not knowing which pole is what. So we understood that north pole is attracting the south pole and south pole is attracting the north pole. That is why this already existing magnet was coming to rest in the north-south direction. Okay, now when I remove the magnet also, still the magnet is going to be in the north-south direction. We need to find out how is this happening. The same principle is followed in the magnetic compass also. When you're watching the magnetic compass, it is showing you certain directions, yes or no? But are you holding a magnet underneath the magnetic compass? No. Do we do that? Am I going to hold a magnet under my magnetic compass so that the pointer is showing me north direction? I don't do that. But then how is my magnetic compass showing the north direction? There must be some invisible force over here. That invisible force is nothing but the earth magnetic field. Okay, there is a huge magnet inside the earth. Do you understand? There is a huge magnet inside the earth and the polarity of the magnet is south and north respectively. So when I hold the magnetic compass, the north pole of the compass is actually pointing to the geographical south of the earth. Yes or no? Or that what did we study? Opposite poles are going to attract. Did you understand? If this pole was north pole, then the pointer would be pointing down. Okay, then the north pole of this compass would be down. Did you understand? When I hold my magnetic compass in my hand and it is showing me north pole, am I holding a magnetic bar underneath it? No, I don't hold a magnetic bar underneath it. Then how is my magnetic compass showing the north direction? It is showing me the north direction with respect to the magnetic field of the earth. This means the earth also behaves like a magnet. There is a big magnet inside the earth. There is a big magnetic field inside the earth, which is helping the magnetic compass to show the respective directions. Okay, now how is the magnetic compass going to show the proper directions? If this was south pole, okay, if this part is south, only then the magnetic compass is going to show me the north direction. Similarly, if this part is north, only then the compass is going to show me the south direction. Why? Because the opposite poles attract. Did you understand? If this pole was north pole, the pointer would be pointing opposite. So what does this mean? That the geographical north of the earth is nothing but the magnetic south. Did you understand? The geographical north of the earth is nothing but the magnetic south. And the geographical south of the earth is nothing but the magnetic north. Just like this. Can you see north and south and north over here? Opposite poles were coming together. Now when I remove the bar magnet and I place the earth over here, you will understand that this analogy over here is correct. The magnetic north is nothing but the geographical south of the earth, and the magnetic south is nothing but the geographical north of the earth. So this shows that earth actually behaves like a magnet. Only because of this reason you're able to hold the magnetic compass in your hand and you're going to move anywhere on the earth and you're going to get the respective direction. Okay, and we don't hold a bar magnet underneath the underneath the magnetic compass, so that the pointer is coming to a certain alignment. We are not doing that. I am not carrying a bar magnet and a magnetic compass whenever I'm going to hiking or whenever I'm going to a journey. I'm only carrying a magnetic compass with me. That particular magnetic compass is going to tell me what is the north direction, what is the south direction and the respective directions. And how does it tell? It tells me because of the earth's magnetic field. This means the earth also behaves like a magnet. So if the earth behaves like a magnet, and we know that unlike poles attract, so if the north pole, if the magnetic compass is showing me the north pole, this means it is actually pointing to the geographical south. Did you understand? And if the compass is showing me the south pole, this means it is actually pointing to the geographical north of the earth. Okay, so we will deal about this with later. So class, okay, we need to find out whether the given object is magnet or not. So what do I do for this activity? I am going to take 3 blocks, okay, of same color, size and shape, but made up of different materials. What did I do? How many blocks did I take? I took 3 blocks of same size, same shape and same color, and I name it as object 1, object 2 and object 3 respectively. And what is the only difference between them? That they are made up of 3 different materials. Now I am going to tell you how are these going to react when I bring them closer to a bar magnet. Okay, for example, the first object. If I bring the first object close to a bar magnet with the poles, north and south. If this is a bar magnet with proper poles, the north pole and the south pole, and I bring this object number 1 near the north pole, what do I observe? That it is not attracting. Okay, I bring the same object near the south pole, then it is also not attracting. Then do you think that this particular object is a magnetic substance? No, it is a non-magnetic substance because it is neither attracting nor repelling. Did you understand? It is not showing me any force. For example, this must be a rubber block. Yes or no? This particular first object must be a rubber block. If I take a rubber block and I place it near any of the poles of the bar magnet, there is no attraction or no repulsion happening. Okay, the state remains not affected. Do you understand? A here stands for attraction, R for repulsion, and E stands for not affected. So what do you think I need to write over here? Change observed when brought close to one pole of the bar magnet. Did I see any change happening over here? No, it was a rubber block. It is not going to show me any change. So I write here not affected. This is page number 18. You can copy the table from the board over here. Now change observed when brought closer to the other pole. Did I see any change when I bring that particular block closer to the second pole of my bar magnet? No. The rubber block is going to show no changes. Okay, when it is brought close to any of the poles of the bar magnet. So here also you are going to write not affected. Fine. Now I move to my object number 2. I take the bar magnet and I place the object number 2 near one of the poles of the bar magnet. And what do I observe? That this particular block and the bar magnet are attracting each other. Did you understand? What did I do? I placed the object number 2 near my bar magnet. What do I observe? It is attracting one of the poles. Similarly, I take this particular object or the block near the second pole. And what do I observe again? That this particular object is also attracting near the second pole. Then what do you think this is? It is nothing but a magnetic substance like an iron block. You don't know what are the polarity. You don't know what is the poles. What are the poles of an iron block? Yes or no? So this means, let me tell you again. Object number 2. When I brought object number 2 near the bar magnet, near the north pole of the bar magnet, what did I observe? I observe attraction. When I bring object number 2 near the south pole of the bar magnet, I again observe attraction. So what does this mean? Object number 2 is a magnetic substance. Okay, for example, an iron block. It is not a bar magnet, but it is a magnetic substance. This means it is a certain type of material which is made up of iron or made up of cobalt or nickel. For example, iron filings, yes or no? You remember what were iron filings? If this is the north and the south pole of the bar magnet and I drop some iron filings over here, they are going to get attracted to both the poles. Similarly, this object number 2 got attracted to the north pole as well as to the south pole. So what does this prove? This proves that this object number 2 is actually a magnetic substance. Did you understand? So you will write attraction over here and attraction over here. And what is the conclusion? That object number 2 is a magnetic substance. What did we understand till now? Object number 1, okay, was a non-magnetic substance. Object number 2 is a magnetic substance because it is getting attracted to both the ends. Give me some examples of magnetic substances. Iron blocks, cobalt blocks, nickel blocks, steel blocks, iron filings. Yes or no? They are going to get attracted to both the ends. Okay. Now, I take the third object near my bar magnet. When I take the third object near my bar magnet, I again observe attraction. Okay, when I bring it closer to the north pole. When I take my object number 3 and I place it near the bar magnet and near the north pole of the bar magnet, I observe attraction. Similarly, if I take the object number 3 and I place it near the south pole of the bar magnet, I observe repulsion. Did you understand? What did I do over here? I took the object number 3 and I place it near the north pole of the bar magnet. Okay, I observed attraction over here. Let's write attraction. The same object, I brought it near the south pole of the bar magnet. And what did I observe? I observed repulsion. This means that the third object that I have taken is a proper bar magnet. Did you understand? The third object that I took here for my activity is a proper bar magnet with proper north pole and south pole. This means that the pole that was attracting the north pole of the bar magnet over here was nothing but the south pole of the magnet. Did you understand? And the pole which was not attracting this particular bar magnet over here was the same pole. It was the south pole of the magnet. Did you understand? So what is the conclusion over here, class? What was the activity all about? The activity was all about to categorize what is a non-magnetic substance, what is a magnetic substance, and what is a magnet. Okay, so what did I do for this? I took three objects of the same size, color and shape, but of different materials. What did I understand? That the first object that I took was a rubber block, because it was not attracting to the bar magnet and it was not repelling to the bar magnet. It was not showing me any changes. So that is why I came to a conclusion that the first object is a non-magnetic substance. The second object was attracting to both the ends of the bar magnet. So I came to a conclusion that the second object is a magnetic substance. The third object was attracting to one end and repelling to other end. So what is the conclusion over here? That the object that I have taken as object number 3 is a proper bar magnet with north and south poles. That is why it was showing me both attraction and repulsion. Did you understand now? Let's move further. So now if I take a big or or quite a lengthy one, if I take a long bar magnet with me and I cut it into two pieces, so what do you think is going to happen to the magnet? Is it going to lose its magnetic property? No, not so soon. Okay, if I take this big bar magnet and I cut it into two pieces, so these two pieces individually will again start behaving like bar magnets. Did you understand? Like two small bar magnets. Now if I cut this piece as well as this piece again, then again individual four pieces of the magnets which were cut will again start behaving like four small magnets. So in this way you understand that permanent magnets, however, how much ever you're going to cut them, they are again going to behave like tiny magnets. Okay, so now then when does the magnet lose its magnetic property? When you're breaking it, when you're hammering it, when you're throwing it into water, or you're throwing it on the ground too many times. In this way the magnet is going to lose its magnetic property. The magnet losing its magnetic property is called as demagnetization. The magnet transferring its property, or making a new magnet is called as magnetization. For example, if we want to try to make our own compass over here, what do? We take an iron nail. Iron nail is not a magnet, it is a magnetic substance. It is going to get attracted to a magnet. It is not a magnet, but it is a magnetic substance, class. Do you understand? There is a certain difference between a magnet and a magnetic substance. The magnet is going to have poles, the north pole and the south pole. The magnetic substance here, you are not aware of the poles over here, neither do they have any poles unless and until you make them a magnet. So what do we do over here? I take an iron nail. Okay, now iron is a magnetic substance, everybody knows that. So what do? I take a bar magnet and I drag the bar magnet on the iron nail in one direction. How do I do it? I take the bar magnet, I bring it to the first end. Okay, I bring it to the first end and I'm dragging the bar magnet on the iron nail in one direction. Once I complete the length, I lift the bar magnet and I come again in the start position and I do it again. I do like this for about 20 to 30 times. Okay, what did I do? If this was my bar magnet and if this was my nail and this was my bar magnet, I was dragging the bar magnet on the iron nail about 20 times in one direction only. Do you understand? In this way, this is called as magnetizing a nail. Do you understand? I am transferring the properties of the magnet to the iron nail so that the iron nail starts behaving like a bar magnet now. Did you understand? Once I complete doing it 20 times, once I have dragged the bar magnet on the iron nail almost 20 times in one direction, it is going to start behaving like a bar magnet with proper north and south poles because I have magnetized the nail now. I have transferred the magnetic properties of the bar magnet to the nail. What do I need to take care of? I need not, put back and forth. Should not drag the bar magnet back and forth on the nail. I should always drag the bar magnet in one direction of the nail. Okay, from the start to the end. When you go from the start to the end, you lift up the magnet, again come to the start, drag, and again lift like this. Only in one direction. You are not going to do it in back and forth motion. Do you understand? In this way, there is not going to be any effect on the particular iron nail. So what do you need to take care of? You should not, you should not drag the bar magnet on the iron nail back and forth. You should always drag the bar magnet onto the iron nail in one direction. So what did we do? We magnetized a needle. Now, if I bring some alpins, okay, if I bring some iron filings or alpins to near to this iron nail over here, you will see that the iron filings or the alpins are getting attracted to the ends of the iron nail. This shows that this iron nail has started behaving like a magnet. Did you understand? What did I do? I magnetized a nail. How did I test whether the magnetizing was successful or not? I brought some alpins. Alpins are those pins which you put on the notice board and all. Okay, alpins or iron filings near the iron nail. What do I observe? That the alpins and the iron filings are getting attracted to the poles of the iron nail over here. So what does this prove? That the iron nail got magnetized. It attained the powers of the bar magnet. Now, let's try to make our own compass. What do? I take a bucket full of water to a certain level. Fine. Now I add some detergent to this water so that the water is floaty. What do? I take a rubber cork. Now, rubber cork is nothing but like a rubber pad or, uh, how should I say this? Like a rubber disc. Fine. Now I'm going to take a rubber cork and I'm going to attach this particular magnetized needle onto the rubber cork. Okay. Now I take this setup and I put it in the bucket full of water. The rubber cork floats for a moment and you will see that the rubber cork has come to a certain position. That certain position to which the rubber cork stops is called as the north-south direction. Yes or no? How do you test whether it is north-south? You take the bar magnet, try to attract it. If the south pole is attracting this particular pole of this particular, iron nail, you will observe that this is nothing but the north pole of the iron nail and this is the south pole of the iron nail. So what do you conclude from this? That particular magnetized nail, which now behaves like a bar magnet, with the help of the magnetized nail, you can actually create a compass. What did I do to create a compass? I took a bucket full of water and I added some detergent so that the water was floaty. Then I take a rubber pad or a rubber cork and I attach my magnetized needle on it and I place it in the bucket of water. After some time, the rubber cork comes to a certain direction where the needle is pointing to a certain direction. So you need to understand that the needle or the nail has started behaving like a bar magnet. This means it has come to rest in the north-south direction. How do I test whether it is north-south direction? Bring the bar magnet close to it. If the south pole is attracting this particular pole, this means that the needle is pointing in the north direction. And if the north pole is attracting this particular pole, this means this is the south direction. This means our property was correct. Okay. And our experiment was also alright. We were able to create a magnetic compass over here. And that particular nail is actually pointing in the north-south direction, thus behaving like a proper bar magnet, thus behaving like a magnetic needle. Okay, now let's study about a very important topic over here, magnetic induction. If I take a bar magnet and I place a safety pin very close to the bar magnet, you know safety pin is a magnetic substance. It is going to get attracted to the bar magnet. That is what is shown over here, that that particular safety pin got attracted to the bar magnet. Now I place another iron nail to the safety pin. Okay, I am not placing the iron nail to the bar magnet. I am placing the iron nail to the safety pin. What do I observe? That the iron nail gets attracted to the safety pin. Why do you think this is happening? This is because the bar magnet is transferring its properties to the safety pin, and the safety pin also starts behaving like a bar magnet, and it is able to attach or attract the iron nail. Okay, this property of the bar magnet transferring the magnetic properties is called as magnetic induction. Let's recall again. So what do we have over here? We have a bar magnet. Okay, now what do? I take a safety pin and I bring it very close, and I completely in contact with the bar magnet. What do I observe? That the safety pin got attracted to one of the poles of the bar magnet. Now what else do I take? I take an iron nail. Where am I placing the iron nail? Am I placing it on the bar magnet over here? No, I am placing it on the safety pin. What do I observe? That the iron nail is also attached to the safety pin. Why is this happening? Because the bar magnet, the original bar magnet transferred its magnetic properties to the safety pin, and the safety pin started behaving like a bar magnet again, and the iron nail was able to get attracted to the safety pin. This property of transferring the properties, okay, this transferring of properties from the bar magnet to the magnetic substances is called as magnetic induction. Induction is nothing but inducing. This means, enabling the property, the magnetic property in the magnetic substances. What is the meaning of induction? This means inducing or enabling or transferring the properties from the bar magnet to a magnetic substance. Okay, now when I put it apart, okay, when I take this away, I place the safety pin and the needle over here. Are they going to get attracted now? No, because they are not attached to the bar magnet. Did you understand? Neither did I magnetize them like our previous activity. I performed no magnetizing or no demagnetizing over here. I just pulled it apart and placed it somewhere else. And what do I observe? That they are not attracting to each other now, because they have lost the magnetic induction. Okay, this was a first case. What is the second case? I take the same bar magnet and I place the safety pin a little closer, but not in contact, just a small distance. Can you see the distance over here? It is very less. If I place the safety pin a little closer to the bar magnet, because of the magnetic field of the bar magnet, the safety pin is going to acquire certain properties of the bar magnet, and it starts behaving like a magnet again. And how do I test whether it is behaving like a magnet again? Because it is attracting the nail. Did you understand? So what does this mean? If I completely attach the safety pin to the bar magnet, it starts behaving like a magnet. If I keep it a little away, this means if I keep it in the vicinity, or if I keep it in the magnetic field of the bar magnet, the safety pin still starts behaving like a magnet because it is attracting the iron nail. But if I keep it completely away, from the bar magnet, it is not going to have any of the magnetic properties, and it is going to behave like a normal safety pin and a needle. Did you understand? So what do I understand from the second case over here? I understand that the bar magnet, around the bar magnet, there is a certain field called as the magnetic field. If I place anything in this magnetic field, it is going to get attracted to the bar magnet. If I place anything away from the magnetic field or outside the magnetic field, somewhere over here, do you think this particular block is going to get attracted to my magnet over here? No. For any of the magnetic substances to get attracted to the bar magnets, they need to be placed in the magnetic field. In the first case, I was placing the safety pin very, very close, completely in contact with the bar magnet. In the second case, I was placing the safety pin in the magnetic field of the bar magnet. That is why the safety pin was able to behave like a magnet and it was attracting the nail. But in my other case over here, I was not placing the safety pin close to the bar magnet or in the magnetic field of the bar magnet. I was keeping it very away. That is why it was not able to behave like a magnet, neither it was showing any attraction or repulsion. Okay class, so that's the end of the lesson. Okay, so let's write down Sakshi. Classwork. Lesson number 2 done. Homework. I want you to read the lesson thoroughly, line by line. It is really simple. All you learn in this lesson is about magnet and its properties. The directional property, attraction property and repulsion property. You learned how to magnetize a needle. Okay. You learned how to use the magnetized needle to make your own compass. You learned that when you break the magnet into smaller pieces, it starts behaving like tiny magnets. What else did you learn? You learned about the transferring of magnetic properties. What is it? What is this process called as magnetic induction? Okay, and the transferring of magnetic properties can only happen when the safety pin or the iron nail is placed in the magnetic field of the bar magnet, or it is completely in contact with the bar magnet. Only then the magnetic induction can happen. Otherwise, it is never going to happen. What else did we study, class? We studied about that Earth behaves like a magnet, how are magnetic compasses used, how to find out whether the given substance is a non-magnetic substance or a magnetic substance or a magnet. Okay, hope so you understand what was taught, and you will understand only if you go line by line to every word and you re-watch the videos and try to understand what was actually explained. Please open up textbooks and start learning. Start reading word by word. Reading is really important for science. Only then you can understand what are we actually talking about. So the name of the lesson was playing with magnets. We are done with the lesson. Sakshi is the classwork that lesson number 2 is done, and homework is you have to read the lesson 2. Please read the lesson number 2. Okay, thank you.